Okay, now we're going to talk about file modes and permissions. If, for example, I decided to create a file, before we even start, let's take a look at our present working directory, or PWD, and then let's take a look at the mydir subfolder or subcontainer of downloads, and we're going to use the long version of the ls output, and that is different than the standard ls output because we just get just the file names. However, with the -l or /l, or shall I say -l? I should. We get more detailed information, such as all of this seemingly gobbledygook here, and we get all this other information which may seem more obvious, like it's obvious that this was when the file was created. This might be, for example, actually this would be when the file was created, and then this is like how big the file is. And of course, my field 3 is going to be a little bit bigger than my field 2. So if instead we said my file 3.text and we did a stream of it, you can see why that is a certain size and the my file 2 is a lower size. So that's obvious, but that's obviously the sizes. The question might be, what is all of this and what is this? So let me just show you something before I explain this. Let's go to clear and let's go back to this command. I'm going to go ahead and do touch, and then I'm going to create another file. I'll say my file 5 and press enter. Now if we do an ls-l of all the files within mydir ls-l, we can see that my file 5 has new information right here, JSON. So this refers to who actually created the file and what group this person is in. And Linux has a weird thing. Maybe it's not weird, I should say, but Linux has this thing where when a certain user is created, he automatically there is another entity that's created, the group, and that person's group is his username. So when you create a new user, we'll call it user John Doe. The group John Doe is automatically created, and John Doe is automatically put as a member of that group. So they always say the differences between a user and group is a user just kind of owns processes, and a group decides where the user can go, because it's a lot easier to create permissions and control and maintain permissions with groups than it is in users. And it kind of flows with the overall theme of this system admin course. Because as a system admin, one of your core jobs is deciding where everyone can go to, deciding the user limits. And so the limits that you place, on people that log into your system is easier. It's easier to control things by groups or categories than it is by singular files or singular people. So you can imagine, if you were creating an overall system for, an arena in which you have a band playing or a comedian or some sort of performance like a play, and you decided, okay, I have, as a security guard, I have to determine who can go where and who can go what. So you wouldn't control people by the actual person, okay? You would control people by groups. So the idea is you put people in groups. So you control things. So that's the whole purpose of groups in the first place, is you control people not by users, but by groups. Okay, so if I could draw your attention to the boxes on the left, this is just a Word document right here. I've drawn two boxes. One is Jason. One represents not only the username Jason, but the group that the user Jason belongs to represents this left square, and this right square represents the user test, and the user test is part of group test. And I just want to show you that whatever I'm going to say, archives or whatever things that Jason creates, whether they're Word documents or PowerPoints or any type of intellectual property, if they are done in a certain way, then Jason and only Jason can get to them. Now, we have the thought process of just saying access, of just thinking access. So in other words, anything that Jason creates, that means because they're in separate groups, you can make it so that only people in Jason's group can get to it, and if Tess wants to get to it, that is blocked off. So if yet another person in Jason's group joins, then they actually have access to this, and we can make that into a green arrow, meaning they can have access to this intellectual property. But how can we depict that? How do we depict that in a Linux type command line system? Well, we can use the ls-l syntax to actually show the permissions. And that's what this is. It is a fancy way to depict all of the permissions for this file, myfile5.t. Let's take a look and focus on this last line right here of ls-l, output for downloads my dir. And here it is, kind of more detailed, kind of bigger on this PowerPoint slide in this week's deck. So let me just get a marker right here. So this represents the user, and this represents the group that the user was in. This represents the file name. This represents, when it was created and or modified. This represents the size. I'll just circle it a big fat 0 because there's nothing inside the file. I just kind of created it through the touch command. Now here is the main event, if you will, and let me just grab another color here just because it doesn't just show up on this slide deck very well. So here is the output that what we're really concerned about. So what is this cacophony or gobbledygook, if you will, of syntax right here? So this represents kind of like a string of characters, and each position is important, and really there could be a natural barrier, if you will, between them. So the first barrier is here, the next barrier is here, and the next barrier is here. Now, in case you're wondering, it just seems like it's awfully random why these barriers exist. It'll make more sense in just a second. So first off, if we look at this, this represents the type of file, and I'll even put T right here for the type. Now, when I say type of file, I should mean the type of entry that it is. So, for example, if this is a regular file, it's going to be just showing a dash, and that's going to be 99% of the output right here. Now, if it shows, for example, a D right here, that means it's a directory. So let me kind of demonstrate that for you here. If I just went up a level and I just press ls downloads. Oh, actually, let me just type in CD, and let me please ignore what I just did. Now, if I just press list directory of just downloads and press enter, we would just have my dir. Okay. Now, if we just put in, for example, If I just did ls, we'd see downloads, and we'd see all these other files that were in downloads. I'm going to type in clear. Now if we said, and let me move this down a little bit, if we said ls-l, and we would see that we have a long listing of the directory contents right here, and we now can see, oh, we have things that begin with a dash and things that begin with a D. Well, that's what I'm saying. When it begins with a D, that means it's a directory. So if we just did the short version, we would see it's obvious that downloads is a directory, and desktop is a directory, music is a directory, whereas these are just files. Here is my dir as well. Now you can see, now this is interesting. We can see that it might not be obvious that my dir is a directory versus pictures and templates are directories, and that's because public videos and templates, those are system directories that that comes with the kernel download. So if we just had a blank shell of an operating system, you wouldn't see my dir because we created that ourselves, but you'd still see pictures, templates, videos, documents, desktop downloads. So anyways, this listing is important because as you can see, it's showing my dir as not being a directory. Okay, I apologize when I made that last micro video showing my terminal and the very top of the commands were cut off, and I apologize. I will not do that again. So I made sure we had plenty of room on the top. So let me explain some of the issues with that first listing. So we have ls-l, and just so you know where we are in the present directory, we are at my home prompt, my home level, if you will. And we're going to do ls-l, and again, as I mentioned before, we have my dir right here, and we can see that does not have the prefix D. So that indicates anytime you see a dash, that's just a regular file. And so there's dash, and there's D, and there's L, which is a linked file or a symbolically linked file, and that's a little bit above our pay grade for now. We'll get into that in the next couple of weeks. But for now, the only first characters you need to worry about is if it's a D, it's a directory. If it's a dash, like here, that means it's a regular file. Now, as you can see, the contradiction right now is here is my dir. So if we said ls downloads, and then my dir, that has files in it, so we can't really call it, it is a directory, but it's actually a subdirectory. So let me type in clear, and let's go ahead and make another directory. Remember, we are at my home directory, so I'm going to make a directory not as a subdirectory on our home, not as a subdirectory, but well, it will be another directory if you look at it from the standpoint of JSON being the home directory. Now, if we can move up into the file, if I just do CD and then keep on doing this, and then move up, if we do present working directory, and I did ls, there are all the base files, I guess you could say, directory for our system. So we don't want to mess with that. That's like for the root access. That's for the root part. That's beyond even my pay grade. This goes back to the dawn of time when Linus Torvalds actually created Linux from Minix. So we're going to do our directory right on our home directory. So this current directory will be a subdirectory directly off of our home directory. So I'm going to say make dir. I'll just call it HAL in HAL. If you've ever seen 2001: A Space Odyssey, you'll know what I mean. Make dir HAL. That's of course the program or command to make a new directory. Now, if I type in ls, we can see HAL, because it's not a subdirectory of one of these subdirectories, because it's a subdirectory directly attached to my home directory. You'll see that it is in blue. So if we do ls-l, and I'm just going to say grep HAL, So we'll only show, the directory, the information for Hal. We can see that it is actually does show the proper term, the proper letter, prefacing all this other information that we actually want to get into. We don't. The point of this whole mini portion of these videos isn't necessarily this part. I just spent probably a little bit too much time on this part. The point is, I want to talk about these, and we'll get to that right now. But I did want to say that I did kind of rectify as to why is it that this my dir didn't have D in front of it and this one does. So hopefully I explained that to you. And for I guess posterity's sake, let's do ls-l and forget the grep. Let's just list everything, and you can see this is what Hal looks like with everything. So everything in blue, which is it's a subdirectory, but technically it's a subdirectory, but it would be one of our main directories, and they're pre-made too. And all the ones in blue here get the D indicator, and the rest. And the only dir that doesn't get the D indicator is this one, my dir, and that's because it is a subdirectory of an existing subdirectory. This cacophony or this weird looking string actually means. So as I tried to show you in that other slide, we can divide these up into threes. So that's character 1, 2, actually let me just put a line here. So this is where it's either a dash or it's a D, as we mentioned before. If it's a dash, as I said before, it's a regular file. If it's a D, then it indicates that line entry is in fact a directory. And unfortunately, there's no real way to distinguish it from a subdirectory and a regular file, because as you saw, both a subdirectory and a file are going to be indicators with indicating a dash. Only a major directory is going to have the indication of D, but that's just the way it is. Now, the main event. What are these other things here, which you're probably wondering? So we can call this cluster 1, we can call this cluster 2, and we can call this one cluster 3. Now, I'm going to do something I didn't really plan on doing. I'm going to bring this in here, and I'm going to say ls-l. Now, notice I keep on doing -l because L is the only, gives us the quote-unquote long listing, and that is pretty much everything we actually need. That gives us most of the information that we need. And again, if you need explanation about what are these little dashes and characters after ls. ls is easy, listing, but these other dashes might be confusing to you. Well, man ls will give you all the information, but really, just Google it. Make it easy, just Google it. Anyways, the other thing I wanted to do is to show you that, hey, each of these has their own weird code in front of it. So what does this all mean? So when I divide it into threes, the same thing goes for all these. So the first character is taken by itself, and then the next three are considered together, and then the next three are considered together, and the next three are considered together. And that's for all of these files. So what are they trying to say? Why do we have to link? How are these three linked to each other? And why is it that these three are linked to each other? And the same thing with these three. And why are they different? And what does R, W, and dash mean? Well, if there's a letter there and not a dash here, this dash and this dash are two different things. So this dash right here, and I'll explain this in further detail next week too. The first time you're hearing this, you probably are kind of like, what is going on here? This looks like hieroglyphics or something like that. This looks like nonsense. This looks like cacophony, just a bunch of random letters and dashes, but there's an order to this madness. So we have R, W, and dash, and I just got through telling you if there's a letter there, that means that permission exists. And if there's a dash here, that means that that permission does not exist. So apparently, within this cluster, RW, those permissions exist and dash doesn't. But what does R and what does W mean? Well, let me go ahead and bring this text box here, because with my writing, it can get sloppy because I write like a 3-year-old. Anyways, we have R, W, and the other possible permission is X. So what I'm going to do now is I'm going to put this right here like this and put this like this, and let's see if it does that stupid capitalization thing. So what do you think R means? If you have a text file or something like that, or any file, what do you think R could mean? Well, R means to read. So in other words, if the letter R exists there, that means we can read it. Well, wait a second. Who's we? Well, you have to, when I group these into threes, there's a natural order to how Unix or Linux system reads these. It reads it sequentially left to right. And so if it looks at R and, it sees that R is there, that means that the user himself is allowed to read the file. Okay? So let's say, how does this work with a Linux type file? Let me bring up the my program right here, my terminal. What does this mean? Well, if you take a look at ls-l, and then I'll do grep, and I don't know, we'll do my dir.text, and we can see that the permissions, what does this say? Dash, that means it's a regular file, and that checks out. It's just a text file. And it also means that this is the user permission, the first 3 characters. Okay, go back to this. The next 3 characters are group permissions, and the next 3 characters are other permissions. So we have user, so that means me as a user, as in Jason as a user. Now, that group, now it's not intuitive to people, to you, but it is kind of strange that when I created a user Jason, and of course you saw me create it during the installation of Debian, because Debian says it's okay, you need a root user, but you also need a regular user, because that's the whole point of sudo. The whole point of sudo is that you should be acting as a regular user as much as possible, and the only time you really need to be root is when you need something that's admin rights necessitated, right? Like creating directories and installing files. That's an admin user, so you can turn yourself momentarily into an admin user by using sudo. So really, your sudo password and your user password should be different. So if somebody, if you go to the bathroom and somebody takes over your computer at work and they're in user mode, they can't maliciously delete files, okay, because you have to be in sudo mode. So if they don't know the password, that protects your system. Okay, so that is your user. But even when you create an everyday user, it creates a group of the same name. So you're a group of 1. So if we created another group called, I don't know, interns, or if we create another group called engineers are probably going to need access to a lot of stuff, like engineering drawings and a lot of intellectual property. So you would think that, whatever group of the engineers are, this would be different. But in this example, I'm just giving this as an example, the group I'm in can only read, but they can't write. And then finally, others can read, but they can't write, and they cannot execute. By the way, an executable is a specific type of file that you actually have to set up as an executable. So you're not going to see really any text file that can be quote-unquote executable, because you're not doing anything. You're either reading or writing it. Incidentally, by writing, or W for writing, that means you can edit it.